Welcome students, this is the 25th lecture on digital lens surveying and mapping. In today's lecture I am going to discuss on different errors in total station. Now this lecture will be discussed under following heads: introduction followed by the calibration, and then the different errors in total station followed by summary, further reading and review questions. Now you know that there are three axes that is available in total station. One is that horizontal axis, then vertical axis, horizontal axis, vertical axis, and line of collimation or axis of sight, line of sight axis. So these are the three axes already I had discussed, that the line about which our telescope rotates, that is the horizontal axis, and the line about which our whole total station rotates in a horizontal plane, that is the vertical axis when perfectly centered and level, and the line of along which we do see the object, that is the line of sight. Now this line of sight should be perpendicular to horizontal axis, then our horizontal axis should be perpendicular to vertical axis, as well as our line of sight also should be perpendicular to the vertical axis. So these are the three conditions which any total station should satisfy, and then we call that the instrument is permanently adjusted, and these three conditions have to be satisfied by the total station before we start taking the observation. So this is the prerequisite condition to make use of total station, that our horizontal axis should be perpendicular to the vertical axis, our line of sight should be perpendicular to the horizontal axis, and also line of sight should be perpendicular to the vertical axis. And this is the ideal condition, but practically hardly we find that our instruments are exactly permanently adjusted. So we need to take care if there is any lack in permanent adjustment or not. If there is any lack in permanent adjustment, that leads to some errors. So that is what we will be discussing today, and it has been found that if we go for both phase observation, that means our direct mode and reverse mode. So like direct mode is this one, and if we see this one is the reverse mode. So we will have and if we take the average of these two reading, then mostly or most of the errors can be avoided. But unfortunately in the field hardly we go for both mode of observation because of limited. Now you can see in this instrument also, if I want to take measurement from this side, I will not be able to take because I do not have the data collector this side. So due to limitation of the instruments, also due to various other reason, generally we do not go for both phase observation in total station, or we can say in the industry single phase observation are most rampant. So we need to know very well what are the different types of errors arises out of the lack in permanent adjustment of the instrument. The error that arises due to lack in permanent adjustment of the instrument can be measured and then taken care of through a process called calibration. So first we need to say what about calibration. Actually whenever we use our instrument, or whenever there is a difference in temperature, that means there is a fluctuation of temperatures, or whenever we transport the instrument from long distance, or again the permanent adjustment of the instrument gets changes. Also the calibration parameter of the, that means the calibration parameter of the instruments gets changes due to mechanical shock, temperature change, rough handling, etc. And that those parameters has to be recalibrated and has to be fed to the instrument, so that during our observation it takes care of those parameters automatically. So, and that can be done some by making use of some standard calibration process that is available, and we should go for calibration of the instrument before we start the instrument in the beginning. That means when we have purchased a new instrument, to start observation with the instrument we should go for calibration. Now if we want to use the instrument after long storage, that means for a long time if we have not used the instrument, then we should go for calibration before we start to use. If we transport the instrument for a long distance, there may be some jerk or rough transportation, so we should go for calibration. Then if we in the field also, if we see that there is a large fluctuation of temperature, then also we should go for calibration, and more specifically when we want to go for very precision work, we should go for calibration. Now one thing has to be remembered, that before we calibrate the instrument, the temperature of the instrument should be maintained its ambient temperature, that means temperature at which it functions properly. Now once calibration has been done, those parameters will be uploaded inside this software automatically, and the software will take care of these parameters of its own. So calibration process also done, once it is done it will be automatically taken care of by the instrument. Now due to the lack in permanent adjustment of the instrument, that means if the horizontal axis is not perpendicular to vertical axis, if the line of sight is not perpendicular to horizontal axis or vertical axis, then there are different types of error that will come across, and also some other error that will come in total station, like horizontal collimation error, tilt axis error, vertical collimation error, compensator index error, eccentricity error, circle graduation error, collimation laser pointer error. These are the main errors which generally we find with the total station, and we have to taken care of these errors primarily. Now to take care of these errors, actually we should regularly calibrate our instrument, preferably in the field, before we go for any measurement, and that will reduce or eliminate most of these errors in our measurement. Now the horizontal collimation error. Horizontal collimation error, it is when the line of collimation or line of sight is not perpendicular to horizontal axis. That means if this is the telescope, this is the line of sight, we will be passing through this, and if this line is not perpendicular to the horizontal axis, then horizontal axis will be like this, and our collimation axis should be perpendicular. If it is not, then suppose it is inclined. So if it is inclined, then there will be some axial rotation. So this is our horizontal axis about which our telescope is rotating, and this is our line of sight. So line of sight is not perpendicular, then we have the error like this. This is called axial error, and due to this axial error, the reading in horizontal circle reading will be affected. So, horizontal circle reading means we will get wrong horizontal angle. So, if we get the mistakes or wrong or there is error in horizontal angle, then that will lead to error in position as well as other parameters. Now, these error will be severe if the line of sight is steep. That means, if I say like this or like that, so that will be still severe. Now, as I told you that if we take both phase measurement, so like this is the phase right measurement or reverse sight, reverse mode, and if we take the left, or you can in case of total station we say that is the original mode, or then if we take this mode as well as this mode measurement, and if we take the average of that, that means both phase left and phase right condition, then that average will provide us with eliminate these errors. So, if the phase left condition, our line of sight is like this, and in the phase right condition the line of sight will be like this. So, this will cancel each other in the horizontal angle measurement while we will take the average. So, this is the idea behind the line of collimation, horizontal collimation error. But as I told you, in the industry or in the in use of total station, the use of single phase measurement is rampant. So, we need to take care of it through calibration. Through calibration we can we do find out the value of C, the angular error in axial angular error, and that will be made available in the total station, and the software will take care of it, should be within certain limit. So, in the manual it will be written what is the limit which is permissible. Now, if this limit, if the calibrated measured value, if the measured value of C is greater than permissible limit of the instrument, then we should send our instrument to the manufacturers to make this correction in the laboratory or in their factory. So, that is all about horizontal collimation error. Next, the tilting axis error. Tilting axis error. Now, this happens when the horizontal axis is not perpendicular to vertical axis. That means this axis is not perpendicular to this. So, the vertical axis plumb line, and the horizontal axis is this one. So, if it is not, if the horizontal axis is not perpendicular to vertical axis, then it will cause the plane of the line of sight, incline as we plan. That means, if we keep this telescope horizontal, then there is no problem. But if we want to see this above or below, then this tilting axis error will cause a reading loss or error in horizontal angle, cause the plane of line of sight inclined, that will lead you to error in horizontal angle, horizontal circle reading. Now, these error also can be eliminated by taking the both phase measurement and taking the average. However, this again, as the single phase measurement is rampant, we need to measure the tilting axis, tilting axis inclination, say B. This value again has to be computed using calibrated. Through calibration we have to measure, and once it is measured, then we can get this to the computer software, which will automatically taken care of. Again similarly, if this value is exceeds the, if the measured value of the tilting axis inclination is more than the permissible value, then we have to send again this instrument to the manufacturer. Now third error is vertical collimation error. Vertical collimation error. Now as we know that when the instrument is properly leveled, then our vertical circle remains in a vertical plane. So our that 0 degree and 180 degree line of the vertical circle should be in a vertical line, in a vertical. Now if it fails, if the 0 degree 180 degree is not vertical, then vertical collimation error comes. So as a result of this, the vertical circle reading error in vertical circle reading, it leads to error in vertical circle reading. And so again same thing, again this can be reduced or eliminated by making use of both phase measurement and taking its average. We can, an average provides us the, we can eliminate or reduce, but as the single phase measurement is rampant, also we need to find out this collimation error angle, what is the angle of inclination of this with the vertical. So say suppose it is A, so this angle of inclination has to be measured using calibration, measured by through calibration and made available to the software to do necessary correction whenever we go for our vertical angle measurement. And again if it exceeds the permissible limit, we should send this instrument to the manufacturer for necessary corrective measures. Next, the compensator index error. Now as we know that each of these instrument is provided with some compensator. So that compensator compensates the leveling, that was whenever we do carry out the leveling and centering operation, there is always some residual leveling error which we do finally carry out the leveling using the electronic compensator instrument. Like so here you can see that there are two one longitudinal and another one compensator wheel indicates in this direction, another in this direction. So we call it Y and X. So there are two compensators generally we have, which we do make adjusted to by doing this thing to provide us the exact leveling of the instrument. there is always some error associated with the compensator, one in the longitudinal level, another in the transverse direction. So suppose L is the error in the longitudinal direction and T is the error in the transverse direction, and these two longitudinal and transverse error of the compensator index is also known as 0 point errors. Now these errors also can be eliminated by taking the both phase measurement. However, this because for single phase measurement also we need to know these errors, and these errors can be also be find out by through calibration, or and if the limit exceeds, then we should go for sending the instrument to the factory. So next, collimation of laser pointer. So whenever we use laser pointer in a reflectorless measurement, collimation error or in laser pointer. Now we know that in case of a reflectorless measurement, what we do inside the telescope, this is the eyepiece and this is the objective lens, and the line joining the center of this and the center of this, that is called line of collimation or line of collimation, and also there is a reticle, and the center of this is, if it passes through this is called, from here it is called line of sight. So in ideal case, line of collimation, line of sight and line of collimation are identical. That is the condition we require for our observation using telescope. Now apart from whenever there is a reflectorless measurement, actually you will see that there is a guided path through which the laser beam, we send the laser beam to strike the target. Now if you say this total station, we will find that here there is a mark like this, which is the location for, this is the location for laser guidance. Now the center of that laser guidance should be, the center of this laser guidance and the center of the optical lens should be identical. That is the requirement. Now in ideal case they are coinciding, but sometimes the center of the laser guide or the center of the objective lens do not coincide. Due to this, there is a error of collimation of laser pointer. Now because our instrument gets the measurement by the laser beam, so we assume that the direction of the laser beam is the direction of the line of sight, direction of the line of collimation. Now if there is any discrepancy between, this is the line of collimation and if it is, this is the laser beam, and all the measurements which is done with respect to this, but it is coming to reticle here, so there will be some error, and that error causes errors in both circles of measurement. In order to avoid this error, we can also do the both phase measurement and taking the average. However, for a single phase measurement, again this deviation can be found out through calibration, and that has to be stored in the instrument. So, these are the fundamental errors that is associated with the total station instrument. Apart from that, there are two errors, like already we have discussed that there are two pairs of circles. One is the horizontal circle in this, and there is a pair of vertical circle here, and the whether it is horizontal circle or it is a vertical circle, the center of this, the geometric center of this circle may not coincide with the center of the rotation. So, if there is a discrepancy between the geometric center of the circle, geometric center of the circle and the center for rotation, they should coincide. But if there is a discrepancy between these two, then that eccentricity error comes. Of course, this eccentricity error is also not much, because that is within the instrument, and but this can be avoided by again by taking the average of measurements on opposite sides of the circle. So, we should try to take the measurement, some measurements in this side and some measurements in this side. So, if we take the measurement in both sides, or some measurement this side, some measurement this side, then we can have, taking the average, we can eliminate or minimize this error. Another error is that is circle graduation error. So, this type of error generally arises locus at total stations, where these graduation may not be very fine or precise. So, and there may be very minor deviation in the measurements at some location. So, that will arise the circle graduation error, and this error may be horizontal circle as well as in the vertical circle, and generally we should take measurement at defined location of the circles like so, and then we can minimize or eliminate. So, with this I like to conclude this class, because there are, of course, there are many other errors which I will be taking up in my next class. So, primarily I have discussed in this class about the errors associated with the total station when there is a lack in permanent adjustment of the total station. However, most of the errors that arises out of the lack in permanent adjustment can be avoided by taking the both phase measurement and the average of them. However, in the industry the single phase measurements are rampant. So, we need to go for finding out the measure, we need to measure as well as to remove those errors, and that can be done through calibration process. And before doing any significant work or any precise work, we should go for calibration of the instrument. With this I like to conclude this class. Next class will be on other errors in total station. Thank you.